We'll continue with the example we are working with for writing tests with dependencies. Let's quickly review where we are, and then we'll talk about the next test to write and what problems and issues, and then of course solutions it evolves into. We started with these series of tests, if you recollect. We have done tests for markdown, where our currency exchange will mark down the price for a profit of 2% and return the result. We implemented a few options for markdown and evolved the code through it. Then we implemented a code for getting the rate with no vendors, and then we got a method for getting a rate with one vendor. When we wrote the code for one vendor, we marked out the vendor by providing a interface rate service that the code depends on and implementing that interface in the mock object, which returns a cooked up or canned value, which is a result of 100 in this case. So in this case, we can see that our get rate method is talking to a object, which is a rate service provider, but in turn it actually is talking to the mock object, which is returning that canned value, and then we are marking down the result that we got and returning that result. So as a result, we can see here that the result we got is 2% less than the value we provided. So that is an example of how we can use a mock. But let's go ahead and continue to grow that test and see where this takes us. Let's get back to this example where we have this one vendor and then of course no vendors, but we got to pick another one. We could either pick the vendor which gives an error, or we can use two vendors. Let's go ahead and do the solution when a vendor gives an error. So let's understand what we're going to do first. We're going to write a test with one vendor giving us an error. So let's go ahead and say get rate when one vendor has error, right? So we only have one vendor. When only one vendor and that vendor has errors. How about that? So we have a vendor, but the vendor has error. What do? Well, we could think of exceptions, but I'm going to avoid exception here to simply say that's our problem. The user doesn't care. We need to know what happens when a vendor gives an error. We already talked about this. The vendor, when there's an error from a vendor, we should log it. But what should the user see? Well, if there's only one vendor, I could tell the user, I'll take all your money and give you nothing back. And the user knows there's something wrong and walks away, while we report the problem to our administrators who can go fix the problem. We could politely return an error message saying, sorry, we couldn't process it. But in this case, we'll just return a 0 for now. So I'm going to say assert equals 0, comma, currency exchange dot get rate for NOK. But this time, we want this to be a vendor which has one vendor which has error. Now we know if we don't pass any vendor at all, it gives a 0. So if you run the test right now, the test is going to pass. So when a test passes without doing anything, don't say, wow, we are cool, we are great, and walk away, but instead ask, why does the test pass? It's possible the test is passing because of the wrong reasons. In this case, the test is passing because of wrong reason, because we didn't provide a vendor at all, rather than vendor with an error. So what do we have to do? Well, we certainly want to pass a vendor, so let's go ahead and move that here. Now when we go run the test, you can see the test is failing, and it's because it gave a 9800 rather than a 0. Sure enough, that's what we would expect without doing anything, because the currency value that we get from the mock is 100 when we should be really returning an error. So how do you say this is going to get an error? Well, one way to do that is we could go back to this code right here, and we could say, in this case, throw, let's say, new, and let's go ahead and say runtime exception, error processing, let's say. So we could throw an exception to say something really went wrong when we went to request for the rate from the service. Well, that's great now. So if you look at this, we passed the mock and the mock is failing, and as a result, the code is supposed to handle that. Let's only focus on this one test for now that we are working with. So let's go ahead and run it. It blew up saying there was an error processing. We certainly don't want the error. So what are we going to do? We're going to go to the get rate method, And in the get rate method, we can say, well, let's go ahead and put a try block right here. And we're going to say if everything went fine, return the markdown value, otherwise catch an exception that you get. And then we need to do something with the exception. We're not sure what it is at this moment. So we'll leave it blank for now. And if there was an exception, what are we going to do? Well, sure, we're going to simply return a 0. Obviously, in this case, the return 0 happens here also. But potentially, we could get rid of that now. Well, not exactly, because we have an if statement here. This is internal, so never mind that. So let's go ahead and return a 0 for now and say that we're going to return a 0 when there's an exception that happens. So let's go back and run this one test again and notice that the test is passing. Yay, that's great. However, notice it says 1 of 1, which means it only ran this one test. But let's go ahead and run all the tests, and that did not go well at all. We can see there's an assertion exception here. Hey, what really happened? Well, it looks like we had a failure, and the failure came actually from the previous test over here. And why is that? Because we are expecting a 9800, but it returned a 0 instead. Why did it return a 0? Well, the reason it became a 0 because the mock is now throwing an exception. Wait a minute. We needed the exception here, but not here. What do we do when we start growing these test cases? Well, here is a temptation to fix it. One idea is we could say provide a constructor, and in the constructor I'm going to say Boolean blow up, and here I'm going to simply say blow up equals, let's say the value blow up. I'm going to set that value. We'll say should blow up. How about that? And this case, we have a field that I'm going to create within here. And the field is within the mock clearly. And then, of course, what we are going to do here is when we get the request, we're going to say should blow up is that. And then within here, we could say if should blow up, then throw the exception. Otherwise, simply go ahead and return a value of 100 that we wanted to. Now let's go back and run all the tests, and you can see in this case, oh, wait a minute, this is giving us an error. It says we cannot be applied. Sure, because we haven't passed the value in this case. So let's say false over here, and then let's say true here for it to blow up, because the constructor now needs a parameter. Let's go run the code now, and yay, 8 out of 8 tests are passing. What do you think? Now, if you notice, we did something a little bit ugly. By adding this test, we were forced to go back and mess a little bit with this other test. By adding this test, we ended up failing this other test also. So what we were doing to make this test pass was affecting not only the working of this test, but the code itself. Now you could argue in languages that support default values, we could have said equal to false and avoided really modifying this test, and Java doesn't support that, but nevertheless. But clearly, or we could create an alternate constructor, we could argue. For example, we could leave this as true and leave out the false, and then we could have easily written a constructor that simply takes no parameters at all. And then of course we could have simply said should blow up equals false here, and that would have avoided changing this particular test. But nevertheless, there's one thing that we did we should be very mindful of, and that is we went back to this mock, and now that mock that was a little small suddenly became a little bit bigger. So clearly we are growing the mock, and that's something we should definitely try to avoid it. Now, I remember I was teaching a course on test-driven development in a company, and at the beginning of the session to talk about mock objects, one developer raised his hand and he said he's been using mocks for 2 years and he hates them. I said, well, that's very motivating. Thanks for that introduction, but let me finish this session and maybe I can answer why you are really having those troubles. Well, as I went through the session, right in the middle, about when I came to this part, he raised his hand and he said, okay, now I understand why I hate mocks, and I understand what I'm doing wrong, and I'm already decided that I'm going to do this very differently. So what he has been doing, and a lot of us do, is that we end up growing mocks like this. And if you grow mocks like this, one day you're going to get this very scary question from one of your developers, and the scary question would be, should I start writing unit test on mock objects? Well, that's pretty scary. That's a sign that the mock has just become overblown and overly complicated. So don't do this. So let's revert back to what we had a minute ago. So I am going back to the code we had where we only had this one mock object, as you can see right here, with that one method we had where it was returning a value of 100. So that's what I have right now. And let's roll this back over. We don't have this test. We'll come back to this test. So let's go ahead and run this code, and we can see all the tests are passing. Now we are back to where we were a few minutes ago. Now let's go ahead and write this test. And of course, this test is wrong. We need a mock that fails, right? So that's what we want here. We need a mock that fails, so we need to come back and do this. So what should we really do? First of all, keep the mocks under a very tight leash. Do not go ahead and increase the complexity of mocks over and over. So in other words, here is something to think about. When we have a class that depends on a dependent class right here, a class that it depends on, do not create a mock to stand in for that particular object. That is not going to help us. This is a pathway to hell, and we end up creating mocks that become incredibly hard to maintain, and we end up with what is called a mocking hell. Well, we don't want this situation, so what should we do instead? Well, what should we should do instead is, we have a situation where a class depends on another class. Well, go ahead and write a very first test, and that test doesn't really need any dependency at all. This is the example where we have a test on the markdown, and remember, this markdown did not really need any mock at all because markdown is independent of any dependency. That's the very first step to follow, is simply write this test, and that works without anything on this other side because we don't really need the dependency. Then come along and write your test, which is going to be using the object. Once again, if you look at this code right here, when we said when we have no vendors, this get rate test right here, this test is also an example of test 1, because it is a test that exercises the object, wherein that exercising the object does not require the mock object, the dependency, and doesn't require a mock object as a result. So when the service is null, it bypasses the whole code and simply gets to return 0. So as a result, we don't need any mocks for that. On the other hand, we can think of a test 2, where a second type of test is where the test does require the test requires the code to be talking to the dependency. So notice in this case, one vendor, our get rate has to talk to the vendor. So this is an example where we will create a dependency but introduce a very teeny mini little mock object needed only for that one specific test. So notice what I'm going to do here to make this work. Once again, I will come back to this a little later on. We are still on the test 2 now. So I'm going to go ahead and remove this object from here entirely. And over here, I'm going to say new rate service, as you can see. And obviously, we cannot create an object of an interface. That's why it's giving us an error saying you cannot create an object of an interface, cannot be instantiated. But we're going to override that we're using an anonymous inner class. And so within this, we're going to simply say that we want to return that value. Now notice when I run this code, all the tests pass. But what did we do just now? Well, this little test that we wrote has its own mock object M2. That little mock object is residing and closely tied to this test. Now we are writing a test 3. For test 3 to work, we're going to have its own mock object, another mock. So do not create one massive mock object to represent another object. Instead, create little mock objects where each mock object simply serves one specific request that your code has on the dependent object. Your dependent object could be complex, could have 70 methods. Who cares what it does? But This particular test is exercising your class, and the class is making one small request to the object it depends on. It doesn't care everything else that it may have. For example, if I'm talking to you, you are a fairly complex person, very highly capable. You got so many wonderful qualities. Well, with all respect, I don't care about all of that right now. In this interaction, I might just sit next to you on a airplane, and I may turn over to you and say, hey, what are you reading? I don't care what your name is. I don't care where you are from. I don't care what are your capabilities. I don't know any of those. I don't want to know any of those. All I care about is what are you reading right now. So the mock should simply respond with just that result. Here's what I'm reading. Well, a few minutes may go by, and we may see that the weather turned different and you are getting worried. I might turn to you and ask, hey, where are you heading to? Once again, all I get back from you is the destination. I don't care about other details about you. So in this case, if I want to test this, the first mock will only tell you what you're reading. The second mock will not care about anything else, but tell me only your destination. So in other words, create mocks which are very targeted and focused. A mock is not a representative of an object. A mock is standing in only for that very narrow window of interaction between the code and the dependent object, enough to make the test we are working with to pass. So in this case, what we are going to do is we are going to now say in here, we are going to have a mock that fails. So we can simply say currency exchange dot set vendor, set rate service. And here we will say simply a service, and this is going to be rate service with error. Now, what in the world is a rate service with error? It's a local variable I'm creating within this test equals new, and we will say rate service, and then we will simply say throw new runtime exception error processing. And notice we did not change one mock class. We did not affect any other tests. Now when I run this test, all the tests 8 out of 8 are passing, and we did not step on the toes of any other test. Any other mock didn't become complicated. So the idea is create very, very small interaction points for us to work with. So a mock should really focus on only the specific interaction needed for that test to pass, and not about all the complexities. If your class were to have several methods, if your interfaces has, let's say, 5 methods, this can get a bit complicated if it has 5 methods. But what you can do to avoid that is you can create a dummy class. For example, you can say class rate service dummy, and that implements, let's say, rate service. And then you would implement all the methods here as throw new runtime exception. Let's say over here, not implemented. So you can say not implemented. And then what you can do is you can simply say, in this case, instead of new rate service, you can say rate service, let's say rate service dummy, and then you can override only the method you are interested, and all the others will use a dummy implementation that will blow up if it's called. So you can then reuse that. Once again, you'll be creating instances, an anonymous inner class within this, but you would not be polluting a single mock object. So the moral of the story really is that create little mock objects you need to make those test cases to pass, instead of creating one massive mock object and land into trouble with it. But you don't really need mocks all the time either. So to understand that, let's look at one more test. So the next test I want to work with, well, let's not go into the 2 vendors now. Let's go ahead and say when a get rate should log, let's say should log error when a vendor fails. Well, let's implement this test. It should log an error when a vendor fails. So let's go ahead and say in here, get rate logs error when a vendor fails. Now, clearly for this purpose, we are going to need this vendor which is failing. So let's bring that over here. And so this is going to blow up and throw an exception to say, sorry, I'm going to fail because you're calling the service which is simulating a failure case. Now what should I do? Well, I need to know that the get rate logs an error. Well, it's got to do logging. How do we do that? We could do something like this. We could go to this class here, and in the get rate, in the catch block, what we could do potentially is we could say something like a logger.log, so logger.log, and then we could say error let's say talking to vendor, and then we could specify whatever the details of the vendor we want to specify. Well, that's one way to do this. If we go this route, we're going to talk to a logger, which means we need to externalize a logger just like the way we externalize the rate service, which means right now we would be creating a logger interface. We'll be mocking the logger. Now notice in this test, how many things would we be mocking? We will be mocking a rate service because the service has to fail, and we will be mocking a logger as well. So we would do something like a logger, and we would say logger equals new logger, and then we would implement the logger's log function. So we would say public void log, and then we would say string message, for example, and then we would say something along the lines of, taking this value, setting that into a variable here, and then we would come down here and assert to make sure that that variable was called. But the point really is we'd be mocking the rate service and we would be mocking the logger. That seems like a lot of work to begin with at this very moment. Is there a different way to approach this? Well, it turns out, if you really think about this, yes, we do want a log, but writing to a log is a separate concern from the get rate generating a log message. So in other words, let's rethink about this. We're going to say currency exchange.getRate and specify a particular currency, but what do we want this to really do? We want to say assert equals error processing, let's say, and we want this to be error processing. So error talking to a vendor, and maybe we want to know the vendor's name. We don't have the detail right now, but we can think about those. But error talking to vendor, and then we want to say error processing, because that's the actual error message we got. And then we could say log message. Now, what in the world is log message? We can say string log message is equal to empty to begin with. Now, if we go run all these tests, we will know this current test is going to fail. And why did it fail? It failed because it expected this message called error talking to vendor, but you can see that it did not get that message. It was empty. So what do we do to fix this problem? Well, the idea is that the get rate should have really done some logging, but like we talked about, we don't want to introduce the complexity of the logger at this point while we are dealing with the get rate. So what we could do is we could apply the single level of abstraction principle, and the single level of abstraction principle says you deal with one level of abstraction in your method and leave in fine-grained detail to another method. So as a result, what we could do here is this catch block could simply call log message and or write to log, and worry about don't worry about the write to log method. That can be taken care of separately when we test that independently. So in other words, get rate logs error should simply mean that this function is calling a method called write log or write to log. So how do we do that? Well, we're going to have a method called write to log within the currency exchange. However, we want the get rate to call the write to log. That's what we want it to do. So notice what we can do to make that work. We're going to apply a slight, small little trick here. So we're going to go back here and say the currency exchange, we'll call it as currency exchange. So we create an object over here. So we'll call it currency exchange equals new currency exchange. and we are overriding the class under test right here by providing a currency exchange directly at this point. Now, let's go to the currency exchange itself, and in here, I'm going to go ahead and write a method, and the method I'm going to write is protected, so we'll call it protected, and we can even leave it out if it's the same package that you have access to it. So I'm going to say void write to log string message, and I'm going to simply say throw new runtime exception not implemented yet. So that is all I'm going to do. Simply say not implemented yet, and that is called the write to log. Now I go back to the test, and in the test I'm going to call the get rate, and the get rate is not calling the write to log, so the test is failing right now. So if you run this test, you can see the test is failing because that's not the exception you got. But of course, your intention is for the get rate to call that method. So right here, you can say write to log, and you can say message. Now, what in the world is this message? So message equals, let's say, string dot format, and what should I say here? Well, error talking to, let's say, service or whatever we wanted to call it. So let's go ahead and look at this, talking to vendor. So let's use that term. So error talking to vendor, colon, and then we're going to specify a string, and the string is going to be exception dot get message, and that's the message we get from the exception object. Now let's go back and see how this pans out. Let's go ahead and run this code and see what it does. Well, wait a minute, it still failed. Error talking to vendor processing, it says it didn't get that message. That's definitely failing. And why is that failing? Well, that's because if you look at the line number where the error is from, let's go look at that code. Oh dear, that's right here. It's failing, that the assertion did not go through. Well, wait a minute. We did call the get rate method. So let's go to the get rate method. In the get rate method, we are calling this method where there's an exception in this case. If there was an exception, it should have called write to log, and write to log should have blown up with that particular message. Why didn't that really do that particular action? Well, that's because we did not set the mock on the object yet, did we? So let's go ahead and set the mock properly. So currency exchange dot. So again, you have to make sure the tests are failing for the right reason. So set rate vendor and rate service with error. So we got to set that first. Now let's go ahead and run the test and see what it does. And you can see the test now failed with not implemented yet. And that makes sense because when we called get rate, that called write log, and write log blew up. Now what do? Well, here comes the good news. We go back to our test, and in the test, we override the write to log method. Remember, we made it a package friendly, so we can override it here. And in this method, all I have to do is note down the log message we have obtained at this point. So what I'm going to do here is I'm going to simply move this log message to up here to this portion. And let's say here log message is equal to, and let's say the message we have obtained so far. Well, that gives us an error. Why? Because that we called it final. Let's make it non-final. That still gives us an error because you're not allowed to modify that variable right here from within the inner class. Oh, darn it, what do? Well, there's a way we can easily get around it. We can simply move this message to inside this class, and notice at this point our currency exchange has that particular log message property. So we could write this as a property within this class, and in this case, of course, our currency exchange is an anonymous instance of this currency exchange. So it's really hard to reach into this with that particular name. So what do? We got to have a way to get into this particular method, isn't it? So the idea is, if you don't call this method, it's going to blow up. If you call this method, it should assert here. Hey, how about this then? We can simply come down here and we can say assert equals, and then we could say the message we are expecting, right? So in other words, let's take this assert from here, and we can simply move this into this right here and say this is going to be the message. So in other words, we are saying at this point that if we don't provide this method, as you can see right now, we will see that the test is failing because getRate is calling the method write to log and that's blowing up. But if we do write this implementation, it's going to come in here. Let's now go ahead and run this test and you can see the test is passing. However, don't take that for an answer yet. Let's get back to the getRate method. And in the getRate method, let's call this with a blah rather than the actual message. Now, if I go back and run the test, you will notice that the test is failing and the error says I got a blah and not the error you were expecting. So you can see in this case, it is making sure that the method is being called and it's being called with the right parameter. So that shows to us how we can write this by using the getRateLog method. So the moral of the story is we did overriding of the method to mocking without using a separate mock object. Now that the write to log is implemented with the fake here, well, we can see that it's not implemented fully. So if you try to call this with production code, it will fail, but we can start test driving the implementation of write to log separately, in which case we may create an interface for logger, but that gets postponed into separate concern. And as a result, we are focusing on the fact that getRate is logging, but we postpone the decision as to how the logging itself has to be done, what the interface of the logger should be. All that detail can be postponed. Postponing certain details so we can focus on other more important imminent details is a really good quality we should really try to strive for, and this example shows you that it's doing that. Well, we created mock objects by hand here. We could do that, continue to do that, or we could use some framework to ease the pain. In Java, there are several frameworks, and there is JMock, EasyMock, Mockito, and there are so many other tools available. I'm going to use Mockito here just to show you an example of how we could reduce the amount of code here. So let's get back to one test at a time and see where we can apply Mockito. Mockito is just a tool that's available to create mock objects. So let's go to the first call. That's a init method, not a whole lot to do. Markdown doesn't even depend on anything, so it doesn't need any mocks. So moving forward from Markdown, here it doesn't really require a mock. Remember the example we talked about where the test one doesn't really have anything to do with dependency, so there is nothing to mock away. So that's great. Now here is where we first need a mock. Now, rather than creating this rate service like this, what we could instead do is we could say rate service, for example, here, and we would say, let's actually write it right below and we'll remove the top part. So rate service equal to, let's say, Mockito, and in this case, we will say dot, and we will ask it to create a mock for the rate service dot class. So that tells us create a rate service, a mock for that particular rate service. Now that we have a mock on our hand, we'll say when, and when is a method from Mockito. So we'll go ahead and bring that static import on Mockito's when rate services rate for currency is called with a currency, we'll say currency. And what is this currency we are talking about? Let me say final string currency equals noke. That way we don't duplicate that value, and we will simply say currency here. So in fact, we could even change this to noke currency. How about that? So if we change this to a noke currency, we can use that noke currency here, and we can use it here as well. And of course, we can quietly move this into the class so that we don't have to repeatedly define this. So right there is private final string noke currency. So now we can come down to this code and we can say here is our noke currency that we are using. And now that we have the noke currency, we are sending that to this when. And then what do we do? So back here, Mockito.mock the rate service, when the rate services rate for currency, noke currency is called, and then return. So we're going to say and return. So this is when we want to tell him what to do as a result of this particular call. So let's go ahead and say, in this case, and then return. And what do you want to return? 100, obviously. How do I know it's 100? Well, that's what we're dealing with here, isn't it? So then return the value of 100. Now let's quietly remove this object we created. And this is going to be, of course, the rate service that we are interested in using. So now let's go ahead and run all the tests. And you can see in this case the test pass. Well, I jumped a little too soon. The test didn't pass. Why? Well, we are calling the get rate, of course. And the get rate in this case is calling the unimplemented method when there was an exception. Hey, but wait a minute, there shouldn't be an exception in this case. So why did this test actually fail? So that's one of the beauties is when I think everything is going well, the test tells me not so fast, Venkat, right? Awesome. So let's say what happened in this case. It says not yet implemented. So somehow it called that method. Where did that arise from? Well, right there it came from this particular test. And which is what? Well, that's a test where we have an error being passed in. So it looks like this failed on the test where we do have an error. And of course, this is returning a 0, remember, but it's calling that not implemented method. I'm not sure how I missed this. Maybe I only ran that test alone and didn't run all the tests. So it's time to roll back and fix that bad idea. So sorry, let's step back and roll back from the change we just made. After all, I should make sure all tests are passing before I move forward. So I violated that rule. So let's go ahead and step back and punishment in the make. So let's go back and revert back to what we had a minute ago. So let's go back to all the way. Now, this is an example where if we check in the code periodically, we can quickly roll back the code to the previous version and get back to that particular stage and get moving. So that's something to think about, is to continuously check the code into the version control. I should be doing that as well. If this was production code, obviously, that I'm working on, I would be checking in very frequently, but I should get to that practice even here. So lesson learned. So let's get back to this and see what we're going to do here. So I have the rate service again, back to what we had a minute ago. So let's go ahead and run this test we were working with just to be sure this test is happy. So let's go ahead and run that. And you can see that test is actually passing. Well, that test was simply focused on the fact that this particular service was broken and we had to log. But let's go ahead and run all the tests, of course. And there we go. That test that I had avoided running finally fails and tells me that's failing. Well, what's going on in this case? Well, the problem in this case is, as you can see, that it's supposed to return a 0, but the code is talking to that particular write to method, and that's blowing up because that's not been implemented yet. Now, obviously, if we were progressing through this, we want to really make sure that that particular method is implemented as well. Well, we could use the same technique as we did a few minutes ago to get that implemented, but we don't really care about the error being checked properly. So here's what we can do to avoid that particular problem within this particular test. So we can say currency exchange equals, and then I'm going to simply over here override that one method, and that one method is write to log, but I'm going to just leave it unimplemented. We don't care about that method in this particular test. So you can see in this case, the test is back to running and it's passing. But we'll come back and address that in a minute and how we can actually make that a little bit better. So going back to the other test now. So here is the first test where we need a mock. So this time we should be able to get through that much more quickly. So we'll say Makito. So we'll say in this case, rate service equals Makito and dot mock. And what are we mocking? Rate service dot class. Great, we got that in place. And now we are going to say when. So when this particular method is being called. So let's go ahead and bring the static import for that. So when rate service dot rate for currency with no currency is called, then what do we want to do? Then return, we're going to say 100, right? So that's what we're going to return at this point, the value that we are interested when that happens. Now, obviously, we need a no currency for that. Let's go ahead and define a field with that value, and I'm going to say this is final string no currency equals NOC. And now let's get back to the code right here. So we have a no currency on our hand, and I'm going to say send that no currency here as well as the parameter. So now we are saying if a no currency is given, return at 10,000. So what do I do now? Remove the real mock we had before and change this to the rate service. So what does it do now? Well, at this point, we are using Mockito instead of using hand-tossed mock object. So go ahead and run all the tests, and you can see all the tests are passing. Now let's come to the next test. This one is where things are going to blow up. Now remember, in this particular example, our mock is going to blow up with an exception. So how do we deal with that? Well, let's go ahead and try that. So we're going to say once again here, rate service with error equals Mockito, and then we're going to say dot mock. And in this case, we're going to specify a mock. And what are we going to specify here? We're going to specify that we need a rate service dot class. And once again, we're going to say when, and when what? A rate service with error dot rate for currency, no currency is called. So we're going to specify the no currency here also. So that's going to be no currency. And what should I do at this point? Well, we're going to say, then what do you want it to do? You want it to throw an exception. So notice we are saying if that particular method was called, then throw. Well, what are we going to throw at this point? Well, we want to say dot then throw. And the then throw method says it is going to tell us what exception to throw, the throwable that we want to throw. Well, the throwable we wanted to throw is going to be the exception we are going to simulate. And we know what that is already. Here it is, the new runtime exception, error processing. So let's put that right in there. So now that we have provided that, we can then change the rate service. And then we can now get rid of the mock we hand tossed and use the Mockito created exception, or mock rather. So once again, go ahead and run all the tests. And notice in this case, our tests still pass. And that's because we have used a mock that throws an exception rather than hand tossing. Well, we'll come back to this part in just a minute where we want to take care of this write log. So we'll come back to that in a few minutes. What about this one? Get rate when error, we have a logging going on in this case, right? Well, yes. So first of all, we need this guy, but that's fairly simple to create. We already did. So we could bring in this code, a lot less than what we had a few minutes ago. So we could even wrap that into another function and we can refactor that. We'll do that a little bit later. So this is going to be the one that throws the exception. Well, actually, let's do that. So let's go back to this code and say, well, this is what we want one more time. So grab that and we're going to extract the method. And what is this method? Well, we will call this, first of all, notice it's a private get rate service. Well, that's not what I want to call it as. So what should I call this as? Well, mock service with that throws error processing. How about that? So mock service that throws error processing. So we rolled it into a separate method. And now we can come back here and say, that's exactly what I want to use for the error situation. So now we can see we brought that one here. Well, but the real concern is this one. What do we do about overriding the write to log method? Well, let's go ahead and run this test first of all. Make sure all the tests are passing. Yep, that's good. Now we want to really mock away, but I don't want to use mock to mock away currency exchange because remember, we still want to call the get rate method. Well, for this purpose, Mockito provides what is called a SPY. So I'm going to say currency exchange equals, and I'm going to say Mockito dot SPY. And the SPY I'm going to create is for new currency exchange. So we asked him to create a currency exchange for us from this object. So the SPY is an object that stands in before your real object, and any real code you call, it'll filter through or send it depending on the situation. So now I'm going to say in this case, do return. And what do I want to return? If it was going to return a certain value for us, I would be calling a do return, but it's not going to return anything. So do nothing. And when do I do nothing? Well, do return, if this was not a void method, if this was returning some result, I would call do return. But in this case, it's a void method. So do nothing. Well, do nothing. When do I do this? So when the spy is called, so I'm going to call this as spy. So when the spy is called, so we'll say spy, and we'll call this as currency exchange, spy. So what do I do then? Well, and when the method write to log is called with a message that we are interested in calling. So we can fake out that particular method here to say we are interested in the method write to message being called, but what do I want that to be called with? Well, write to message should be called with a string. So string the message equals, and then I'm going to take that message we have right here, which is the message we really are expecting or anticipating. So let's go ahead and say that's the message I'm really keen in receiving. So now we can get rid of that, and let's see what we just did. We spied away the currency exchange and told it just to proxy out the write to log method and provide the rest of the method on the real object. We are setting up the spy here correctly, but the call should be made on the spy as well. So let's go ahead and change this to spy right here. So now when we go back and run this test, you can see that the test is actually passing. So this shows us how we were able to override this particular write to log method using the spy itself. So, but what if the message is something different than what we expected? We want to make sure that's true as well. So let's go back here, and rather than sending the message, let's say over here a blah. Now let's go back and run this test and see what it tells us, and notice the test is failing. And the reason why the test is failing this time is because we told him to spy this only if this message with that value is being received, but no longer that value is being received. It's a different value. So the spy steps out and says, you go through. And of course, it let the method go through to the real method, which eventually blew up. So the point really is we do want to pass the correct message over here and not deal with the different values. So when we go back and run this, you can see that passes. Now we can refactor this a little bit further. This is creating a spy with that particular message as we are interested here. Let's go ahead and extract that and say create a spy with write to log. So right there is the method called create spy with write to log. Let's go ahead and run all the test cases, and you can see all the test cases are passing, but we have a little bit of an unfinished business, that one. So we can replace that with exactly the call we have here. So we can simply say this is going to be the spy we want to use. So let's go ahead and replace this part again, and we can see in this case running all the tests, we can see all the tests are, well, actually what went wrong here. One more time, in this particular case, we are calling the method with this particular value. Well, sure enough, that's because, again, we are not calling the spy. So let's go ahead and modify the spy. You can see how the tests are really telling that I should be paying more attention to this. Well, there we go. So now let's go back and run this code. You can see all the tests are passing. Let's review what we just did. So we went ahead and used Mockito, and in this case we created a mock. We told the mock, how does this really work? Well, we created a mock object, and Mockito says, all right, I'll proxy out, create an object dynamically for the rate service, and then for the rate service I would return a 10,000 anytime the current rate for currency is called. And so when you pass that to the object you're working with, anytime get rate is calling the rate service, that ends up calling the mocked out value, and the proxy simply returns the value, and that's how Mockito does that. And then we also saw how we can use a spy rather than really providing a separate mock. This uses the real object but filters through and covers some methods. So we saw how to do that. So we saw how to hand toss mock objects. We learned about mocking certain classes by using independent mocks per test. Then we said we could use frameworks. Don't be in a hurry to use framework. Play with mock objects, hand toss them, get comfortable with what they provide, and then decide if you really need to use a mocking framework. Grow into it. We saw examples in C#, we saw examples in Java. Likewise in C#, there are several different frameworks and libraries available. There is nmock, there is a rhinomock. There's also a tool called Fakes, which is built into Visual Studio. If you're interested further into it, I got a video on Vimeo from a conference. You can take a look at it, and it shows you how to use Fakes with C#. So that shows you how we can use mock objects. We'll wrap this up in the next part by discussing when to use mock objects and when not to use mock objects, and then we will take away some lessons we have learned in the process working with this example and a few other things as well.